going to give you a quick proof of the Pythagorean theorem. So suppose we have a square, which means on the corners they're right angles. And I tell you that this distance is x and that distance is y. And I do that to all four sides. Short piece first, x, longer piece is y. Short piece, and then the longer piece. X units, y units. And then I'm going to make what I claim is a square. And I'm going to call the side z. But let's first verify that it is a square. So we know that this is angle, it's a right angle. So this is, say, angle 1, and that's angle 2. And angle 1 plus angle 2, plus angle 2 is equal to the other 90 degrees. Now, these four triangles are similar. They all have a right angle and two legs are equal. That is, opposite the short side is angle 2. Opposite the short side is angle 2. But wait a minute, that's the right angle. So this is 2, that must be 1. And opposite the short side is angle 2. Oh, so that's angle 1. Opposite the short side is 2. That's angle 1. Perfect. Now, we know that this angle is 180. Well, if this part plus this part is 90, that must be 90. And you can make that argument in all four corners. It is a square in there. Okay, I drew on this a lot. Let's get rid of it and make it for a clearer one. Just remember that what I'm calling a square in the middle, it's a square. Okay, so we have x, we have x, and x, and x, and the rest of it is y. And I connect my dots, and I get what looks like a perfect square, except I never listed the y's. And the hypotenuses, since these are all similar triangles, they have lengths of x and lengths of y and the right angle. Well, if this is z, then it's z all the way around. It is the square. Okay, so now we're going to find the area of that whole square two different ways. Each side is x plus y. So on one hand, the area is x plus y squared, which is x squared plus 2xy plus y squared. That's on one hand. On the other hand, the area of this triangle, like every other triangle, is 1/2 times the base, which I don't know, I'll call x, times the height, which I'll call y. But we have 4 of those. That is, so far, I counted over here, I have the whole area. So far, on the line below, I just have this. I just have this, and I just have that. Okay? Plus z squared, which will be this. So that's it. These two are supposed to be equal, these two blue. But let's clean up the bottom one. 4 times a half is 2xy plus z squared. Okay, plus z squared. Now, let's look at what we have. We have this that I'm pointing to, namely x squared plus 2xy plus y squared is equal to this, 2xy plus z squared. Well, I would take away 2xy from both and say I'm done. That x squared plus y squared equals z squared. And remember, x was one leg of the right triangle, y was another leg, and yep, z is the hypotenuse. X squared plus y squared equals z squared. Not because I told you, not because your teacher told you this 5 years ago, but because it is true. We proved it. I know it is. There's no doubt in my mind.